Hi class, this is Mr. Clancy, and we are talking, this is a follow-up on today's class. We had the opportunity to talk about atomic structure, and what we're looking at here is something called isotope notation, or isotopic notation. Which would be right here. The difference, the reason this is so important is that an atom can have different isotopes. So an isotope basically is an atom, or atoms, I should say, atoms of an element with different numbers of neutrons. Different numbers of neutrons. Alright, so basically an isotope notation determines what type of atom you're working with. In other words, which isotope you're working with. This is isotope notation here. Alright, I'm going to try a couple of these for you. We did a couple in today's class on neutral atoms. So in other words, this would be a neutral atom. This would be a neutral atom. This would be a neutral atom. Silver here would be a neutral atom, and way down at the bottom, uranium. All right, so we'll look at that. Basically, to do this assignment, you are going to need a periodic table. All right, so you can use the periodic table sticker that I gave you. You may use the one in your book or on the internet or something of that ilk. There's plenty of them around. If you just Google periodic tables, you will find a bunch of them. All right. Now, what we have here, I'm asking you to complete this chart by element and slash ion, atomic number, atomic mass, mass number, protons, neutrons, electrons. All right. You'll also see that after this, some of these have charges. Do you see this is positive H plus? This one here is lithium plus. This is chlorine minus. This is magnesium 2 plus. This is silver plus 1, and this is sulfur minus 2. What that tells you is those are called ions. Okay, these are ions here. Ions are charged particles. They are not neutral. They are charged particles. All right, if they have a positive, there's two types. If they have a positive charge, they are called cations. If they are negative, they are called anions. And you can have a positive or negative charge by basically an imbalance in the number of cations and anions. With cations, you lose electrons. An electron or electrons. With anions, you gain an electron or electrons. We'll look at a couple of examples. This one here, I'll show you. Let's do a couple of neutral examples first. This is the one we did in class. The atomic number I get right off the periodic table for hydrogen, which is 1. And I am looking at a periodic table which shows an atomic mass. That's the decimal number, the other number, if you will, that's on the periodic table in each elemental box. This will be 1.0079. I will explain later on how we get such an odd number. It's basically a weighted average of all the known isotopes of that particular element. We'll get to that later. The mass number is basically this atomic mass rounded to the nearest whole number, which is 1. All right? The number of protons and the atomic number are always the same thing, so this is going to be 1 right here. And if I take the mass number, which is protons and neutrons, and deduct the number of protons, I'm going to get the number of neutrons. So I could put minus equals All right, and this is going to give me that number of neutrons. 1 minus 1 gives me 0. And this is a neutral atom. I can see there's no positive or negative sign next to it. So as a result, this is neutral, meaning that the number of protons and the number of electrons are the same thing. So this is going to be 1 electron right here. All right, so we did that one in class. I'm going to try a couple more. I'll let you guys try carbon. I'm going to try potassium right here. The 19 below is the atomic number. So in this case, I don't have to look at the periodic table. I've got it. All right. Now I can look at the periodic table and determine the atomic mass, which is 39.10. Notice the mass number is up here at 39. Okay, the number of protons and the atomic number are always the same thing. So this column and this column are always the same for each respective element. Okay, so I have 19 protons here. I'm going to have 19 protons here. All right. Now, since the mass number is the number of protons plus neutrons, and this is the number of protons here, I can take this number and subtract this number to get the number of neutrons, just as I did for hydrogen. 1 minus 1 equals 0. In this case, I'm going to take 39 minus 19, 39 protons and neutrons, minus 39 protons. This gives me 20 neutrons. And because this is a neutral atom, the number of protons and the number of electrons are going to be the same. So this is going to be 19 electrons. All right, so those are the ones with the star. I'm going to put a note here. The star are neutral atoms. All right, neutral atoms in order to do that. So the electrons equals protons in number. All right, so protons and electrons are the same. Now, I want to go up here. I want to go to this box to show you what happens with cations and anions. Remember, cations and anions these ions are charged particles. An ion can either be a cation or an anion. Either one. Cations and anions are created by imbalances of electrons and protons. Remember, the protons, since they determine the identity of the element, can never change. So basically, a cation is created when an electron or electrons are lost. An anion is created when an electron or electrons are gained. Let's look at this example up here. This shows nitrogen 15. This is an excellent template for you to use. Okay, so nitrogen 15. The atomic number for nitrogen always the same, 7 protons. The mass number is 15, which means there are 15. I'll just designate that as P plus N. All right. So I've got 7 protons. I could determine 15 minus 7 would give me 8 neutrons. Now notice there are only 4 electrons in this particular entity. This is positively charged, so this is a cation. Cations are positively charged. Now, how did it get to be a cation? Well, since there's a plus 3 means that it lost 3 electrons. So a neutral atom would have 7 electrons since there are 7 protons. It actually lost the 3 electrons. That designates it with the charge. 7 minus. So if I see a plus 1 on here, for example, it means I lost 1 electron. If I see plus 2, I lost 2 electrons from the neutral number. If I have a plus 3, I lost 3 electrons from the neutral number. A plus 4, 4 electrons from the neutral number, and so forth. All right. Now, if I have a minus 1 here, this would mean I gain an electron. If I have minus 2, it means I gain 2 electrons. If I have minus 3, it means I gain 3 electrons, and so forth. So let's try one here with lithium. All right, we're going to try lithium here to help you get the hang of this. All right, lithium. This is a lithium cation. All right, do you see where it's positively charged here? I'm pointing. That is a cation. The atomic number is 3, as designated here. That means there's 3 protons. All right. I'm going to look at the periodic table and determine that the atomic mass is 6.941. All right, that's the atomic mass, or in effect, the mass of one atom. I'll explain that later, as mentioned. I'm going to round this up to the nearest whole number for the mass number. That becomes 7. All right. So the mass number is 7. That tells me there's 4. This is protons and neutrons. This is protons. 7 minus 3 gives me neutrons. All right. Now, one key thing to remember here is how many electrons are present. Well, if this was a neutral atom, I would have 3 electrons present. But if you'll notice, this is not neutral. This is a cation because it's positively charged. All right. You can see it's plus, which basically means plus 1. So it means I lost 1 electron. So the number of electrons here is basically going to be 3 minus the 1 lost, or 2 electrons. All right, so see if you can try those in a couple. See if you can figure out hydrogen up here. That's an interesting one to try to figure out. You've got another cation here with magnesium. Now I'm going to try to show you an anion to show you how this would work. All right. Remember, chlorine here, this is an anion because it's negatively charged. All right. Let's see. This arsenic is also an anion. This sulfur is also an anion. I'm going to go ahead and do the sulfur down here. For sulfur, I'm just given the elemental symbol. I have to actually go on the atomic number and the mass number. All right, I'm not given that on the table. So if I look at my table, there's sulfur, there's the atomic number at 16, and the mass number is 32.06. All right, so let's try this. Sulfur would be 16. That's the atomic number. Remember, the atomic number and the number of protons is always the same. So let's go ahead and put this 16 in for here. All right. The mass, the atomic mass we just saw was 32.06. I'm going to round this atomic mass to the nearest whole number, which is 32. All right. So now I have 32 protons and neutrons. All right. If I subtract 32 protons and neutrons, I actually get 16 neutrons. All right. So protons and neutrons minus protons gives me neutrons. All right. Now, how many electrons are present? Well, remember, in a neutral atom there would be 16 because there's 1 electron for every proton. Plus 1 offsets a minus 1. All right. In this case, there are 16 plus 2. If you notice the minus 2 over here, that means I gained, an anion gains electrons, I gained 2 electrons. So the number of electrons is 16 plus 2, or 18. All right, there are 18 electrons with that. All right. So what I want you to do is work hard on this through there. You've got a good template to work at. I've done a couple of neutral ones for you. I've done an anion for you and a cation. You've got a couple of challenges that to figure out. Give me your best effort on that. We'll talk about it next week.